this is a good, easy chapter to end on, if you ask me.
Yeah.
So, okay, so measures of central tendency and dispersion. Mean, median, mode that you've been doing since, I don't know, 6th grade, before?
Yeah.
Okay. So, do you remember how to find each of these?
Yeah.
The mean, that's the one where you add all the numbers up,
Yeah.
and you divide by however many numbers are, also sometimes called the average. And when the questions in homework ask you which measure of central tendency best describes the data, well, the mean is best when there's no outliers. So when all the numbers are relatively grouped together and there's no random outlier that's way far away from the others. Okay. Our next measure of central tendency, median. It's the middle number. You just count into the middle as long as the numbers are in order.
Yeah.
So you have to have them in order from least to greatest first, and then it's the middle number. If there's an outlier, so if there's a number that at one end or the other that's way far away from the others, this is going to be a good one to use because an outlier is not going to really affect the median as much. Okay, mode, the easiest one, the one that occurs the most. Okay, that's the best when items are not numbers or you're choosing the most popular. That's your best one to use there. Okay, outlier, I've kind of already talked about that. Number that is much bigger or much smaller than the other numbers. It just makes me think like Sesame Street, which one doesn't belong, you know. And the range. So range is your difference between the greatest and least values. So that's when you're taking the highest value or largest value minus the smallest value is your range. And it describes how spread out the values are. It talks about like the spacing between the highest and lowest value. Okay? So, I guess a practice run here. Find the mean, median, and mode. I'm going to say, does it matter which because I don't know, we're going to probably skip around because with it just being me and you, I don't feel like. So if we go ahead and do the first one. 1, 29, 33, 31, 30, and 33. So you're starting with mean?
Yeah.
And what are we doing for mean?
And all together.
Okay, we're going to add these guys. 1 plus 29 plus 33 plus 31 plus 30 plus 33. 157. And then what are we doing with that 157? Dividing by 6, because there are 6 numbers. Good. And 157 divided by 6, according to the calculator?
26.16.
Okay. Let's go for 1 decimal place.
26.2.
So if we round that to 1 decimal place, 26.2. Okay. Median. What about median? What has to happen first here?
Arrange them in order.
Yeah, they have to be in order from least to greatest. And it doesn't, I sometimes, I used 129, I used 30, I used 31, 33, 33. A good safe check for me is I always count. I know I'm supposed to have 6 total numbers. 1, 2, 3, 4, 5, 6. I have 6 total numbers. And we're trying to find the middle. So 1 and 33, 29 and 33, and 30 and 31 are the middle.
Yeah.
How do I find the middle number when there's 2?
I actually don't know.
Don't remember?
No.
So we want to find what's in the middle of these 2.
30.5.
Okay, so this is an easy one to eyeball. If it's, which is fine, that's exactly what the answer is 30.5. If it's not an easy one to eyeball, then you add those two middle numbers and divide by 2. So 30 plus 31 divided by 2 is going to give you the 30.5. Okay. If you had, so that time we had 6 numbers, we had an even number of numbers, so we had to find the middle of 2 numbers. If there had been an odd number of numbers, it would just be the middle number, right? Okay, moving along. Mode.
33.
Okay, the mode, you're telling me is 33 because it's the only one that repeats?
Yeah.
Good answer. Okay. If nothing repeats, I think we usually say no mode. If multiple numbers repeat the same amount of times, so like 33 repeated twice, if we had another number that repeated twice, they would both be the modes. Okay. It doesn't ask to here, but let's go ahead and practice real quick while we're here. How do I find the range?
I can't remember. Oh, difference between the greatest and least. Okay.
Difference between the greatest and least, so
33 minus 1.
33 minus 1, which is
32.
32. Okay, one last question. Which measure best describes the data? Well, so here's the question.
Oh.
Is there an outlier?
Okay.
So is there an outlier?
Median.
Yeah, because that one right there is an
Oh.
outlier, yes? Because all those other numbers are right there, 20, upper 20s and 30s, right? They're all right there grouped together, so one is an outlier. And so when there's an outlier, it doesn't really affect the median because there's still a middle number. With the mean, because you added such a small number in, it actually pulled our mean down. Because, you still had to divide by 6, but you're only adding a 1 in. So it lowered, if you look at that mean of 26.2, does that really, it doesn't really, it's lower than most numbers, isn't it?
Yeah.
And so that's why that works. So because there's an outlier, the median best describes this set of data. Okay. Can't really fix that very well, but I'm making it worse, not better. Actually, okay, that's supposed to be C and R.
Median best describes. Best describes.
Let's see if I can get the eraser to pop up. Well, DESCRIBES with some extra dots up there. Okay, that makes me feel better. Okay, I don't think we need to do the next one because you know how to find mean, you know how to find median. The difference here, there's only going to be 5 numbers, so it would just be one middle number. Mode, nothing repeats.
Yeah.
So I mentioned earlier that would be no mode. Range you would know how to find. And so this one, I'm just looking at the answer key. If you look, all those numbers look pretty close together, don't they?
Yeah.
So there's not really an outlier. So if you look up here, when no outlier exists, we generally say mean. Now, what I'm looking at here in the answer key, the mean and the median actually work out to be the same number. And so if they work out to be the same number, really you could use either of them in that case. Okay? So, I mean, if there's no outlier, I would be in the habit of picking the mean, but if they work out to be the same number, it doesn't really matter. Okay, let's go to the bottom. I'm more concerned that I remind you how to do this. Find the value of x so that the data has the given mean. This is equivalent to like the word problem you'd see here is Susie has an 80, a 93, and a 91 on her first 3 tests. What score must she get on her 4th test to get an average of 87 in the class? That's the equivalence word problem you're going to see. Okay? So, how do I find x? Okay, so how do we find mean?
Add them all together and divide by the number.
Okay, so I'm going to write it out, add them all together, and so the numbers I'm adding together are 80, 93, 91, and x. And what am I going to divide that by?
4.
Okay, if I know all those numbers, I would divide by 4. And then in this particular problem, what is it supposed to equal? 87. We just wrote an equation to solve.
Oh, okay.
Okay? In other words, basically we wrote out how we'd find the mean, except we have an x thrown in there. So I would go ahead and, did you already add those 3 numbers on top?
264.
Okay, so that means on top I'm going to have 264 plus x divided by 4 equals 87. How do I get rid of the denominator of a fraction? Yeah, if it's dividing by 4, we're going to multiply by 4. If I multiply the left side of this problem by 4, multiply the right side by 4. So when we multiply by 4, the whole point is the 4's will go away. So 264 plus x is equal to whatever 87 times 4 is, 348. And how do I solve for x? Since it's 264 plus x, I'm going to subtract 264. And we're going to get some lovely answer of whatever 348 minus 264 is. 84. So if I go back to earlier in Susie needs an 84 to make sure she maintains an 87 average. Although I'm not sure why you'd want an 87 average. That's like,
yeah, I don't know.
That's like really high B, but not a B plus.
Yeah.
I don't know. Obviously, that doesn't really go with the problem I made up, but okay. So you can handle that.
Yeah.
Do you want to do the next one, or you want to skip to the back? Okay. I'll be honest, I don't remember what's on the back.
Range and mean.
So find the range and mean of each set. Use the results to compare. So they have stock C and they have stock D. Basically, you're taking the numbers in stock C, find the range, find the mean. Take the information in stock D, find the range, find the mean. And then officially it says use the results to compare. I don't know in Math Excel, I mean, you can maybe make a statement that, you know, this has a higher range or lower range, you know, but basically we're just going to find the information here. So stock C is where I'm going to start. I don't know where you started.
I also did.
And I was going to start with range.
I did.
That's all right. No, so you're ahead of me. So what'd you get for range? What are you doing for range?
7 minus 1.
And 7 minus 1 is 6. And we also need to find the mean. My mean can't be 21.
Oh, I didn't.
Not on
I
stock
didn't
C.
divide it. Okay.
Okay, that makes more sense. And here's my reasoning. I'm looking at my numbers. I haven't done any of the math, but my numbers are 7, 4, 3, 6, and 1. How do those average out to be a number way bigger?
4.2. I don't know.
I like that.
It like didn't click in my head.
And I'm just trying to give you some tips along the way of, shoot, I started to say divide by 21 because, what are there, 5 numbers? 7 plus 4 plus 3 plus 6 plus 1. You're telling me it's 21. We're going to divide it by 5 and 4.2. Okay, that's stock C. Now?
24 plus 15 plus 2 plus 10 plus 5.
Stock D. I'm going to start with range just to be consistent. We'll meet up in the end, I'm sure.
Mean of 11.
Okay, I agree. So add all the numbers, divide by 5 again. The range, did you get the range I got?
22.
Yeah. High minus low, 24 minus 2 of 22.
Yeah.
Okay, so, I mean, we can talk comparison here. 22, you know, this range of 22 is bigger. So that means that data is more spread out, more diverse. Whereas a range of 6 means those numbers are very tight together, right?
Yeah.
Okay. Mean of 4.2 versus 11.2, you know, they're two different sets of numbers there, so it's hard to compare, but okay. I'm debating if we need to go in through anything in the bottom or not. I mean, the bottom, it says find the mean, median, mode, and range after you perform the given operation. And
For every number?
yeah.
Oh.
So, and at that point, there's other shortcuts you can do. I don't remember exactly what they are off the top of my head, but if nothing else, you rewrite this list of numbers by adding 4,
Yeah.
right? If you needed information about the group of numbers without the 4, and then the group of numbers with the 4, there are some shortcuts. For instance, notice if you add 4 to all the numbers, it says the range does not change when you add or subtract something. The mode, you would just add 4 to your mode if you think about it.
Yeah.
Because whatever your mode was, is now just 4 more. Median, you could probably add 4 to your median, right?
Yeah.
Now, mean, I'm not sure that you would add 4 to your mean, but maybe you would. Actually, if you're, you just add 4 to all the results, I think. So, the beneficial to knowing that is if you have to do the same set of numbers twice, once as is and once with 4 added, basically you can just add 4 to each of them, each of the results as well, except the range. If you, down at the bottom, if I have this next page, yeah, same data, multiply by 3, notice when you're multiplying, the range does change. You'd have to multiply it by 3 as well. But I'm pretty sure you can just multiply them all by 3. Okay? So I'm going to say just go ahead and get started on homework. And I mean, it really just comes down to if you run into a problem that you don't know how to do. And there may be some of those, but I don't know. I was just trying to pick some good review lesson or some good lessons in chapter 12 that I thought it would be helpful. I'm thinking I should have skipped this one. This lesson was pretty easy. But then again, it's good to review this kind of stuff at times, right? So.